Okay. Um, we're going to look at, actually, not this question. We're going to look at this question first about determining tangents at a given value of x. I picked this one out of Mr. Autry's questions because it looked a little bit challenging and maybe a little bit tricky, but here we go. Here's the function y equals the square root of 3x, and we're supposed to find the equation of the tangent line at x equals 3. Well, we need a point to find the equation of a tangent line, so the first thing might be good to just let x equal 3 in the function. 3 times 3 is 9. The square root of 9 is 3. So 3 and 3 is a point on this function that we want to find the tangent line. But in order to find the gradient, we've got to find the derivative. And we're going to have to do this a little bit different. We're going to have to make this root 3 times root x. And root x is really x to the half power. Well, now it's in a form where we can find the derivative. So we go half of root 3. It's root 3 over 2. We bring it down 1. 1 half minus 1 is x to the negative half. Okay, we need to put this in a form that we can make it sort of easier to put 3 in to find the gradient at that value. We can use this derivative to find the gradient at the x value they gave us. So anyways, x to the minus a half, it's really 1 over the square root of x. We know that x to the half is the square root, but the negative means put it in the bottom. Well, now it's easy. We take x equals 3. We put it in this gradient formula, the derivative, and it's going to tell us root 3 over root 3 is going to cancel. The value of the derivative at 3 is a half. That means the gradient is a half right there. And that's going to give us the equation of the line. We just need y minus y1 equals m times x minus x1. All we've got to do is put a half in for m, put in 3 and 3 for x1 and y1, and we've got the equation of the line. We just clean it up a bit. Y equals a half x minus 3 halves, but we add 3 to minus 3 halves, and it gives us 3 halves. And there's our final equation of the tangent line at x equals 3. Okay, now there's another question. It looked like, it might fool some people, like it may be a little tricky because of the way they give the question, but it's actually only a 3-mark question, and it's pretty easy. They say that g is a linear function and that g of 1 equals 5. Well, that means when x is 1, y is 5. Well, they've given us a point, but when they said that the derivative at 3 is equal to 2, well, that's nice. The gradient's 2. But if it's linear, the gradient is 2 everywhere. So we can just write down our equation for the gradient of a line. The gradient is 2 right there. The point we're given is x is 1 and y is 5. We just put it into the formula, the point gradient formula, and we've got the equation of g. And we just clean it up a little bit. 2 times x is 2x. 2 times minus 2 is minus 2. We add 5, we get plus 3. There's the equation of g in the form y equals 2x plus 3. And that's just about it. Ooh, and I'm stopping recording. Okay, yes.